Greetings and welcome, friends. Welcome, in fact, so much, like 3 times as much as I welcomed you back in Chapter 1. We are in Chapter 3, and this is amazing, right? It's so good to be back with a classic odd number. 2 was prime, 3 still prime. Yeah, this is good stuff. 3, what a good chapter to be in. You guys are going to love this chapter. Today we're talking about section 3.1. About functions. Functions. Fun, right? It's going to be amazing. You're going to love this. So get ready. We're going to think about functions in so many different ways because there's a lot of ways to represent them, and that's wonderful. So let's see. Here it says, a relation, so like a relationship, pairs inputs with outputs. So anything that connects inputs to outputs is a relation. All right, that's the most general, broad case that I've got. When a relation is given as ordered pairs, the x-coordinates are the inputs. Okay, so here we go. Inputs are the x's down here. I've also got examples here. Inputs are the x's. Inputs are the x's. Inputs are the x's, right? So I've got all of these are my inputs. We'll take a look at those in un momento. Por favor. Okay. And the y coordinates are outputs, right? So we get the idea. Outputs, man. There we go. That's a little better. Now, there is a specific case of relations, all right, called functions. And it says this, a relation that pairs each input with exactly one output is a function. So all functions are relations, but not all relations are functions. Kind of like how all squares are rectangles, but not all rectangles are squares. All right. Functions are a subset of relations. Relations have no restriction. It just says, you got an input, here's an output. Right? Whereas functions like, nah, for every input, there's only one output. So it's a little bit more restrictive. So here's exploration 2 from your Big Ideas book. We're going to take a look at, my students have already taken a look at the first 3, or the first C of these. I don't know, that doesn't sound right. But it says, determine whether each relation represents a function. Explain your reasoning. All right, so here I've got an input of 0. It has only one output of 8. Here I've got an input of 1. It has only one output of 8. And 2 gives me 8, 3 gives me 8, 4 gives me 8. Each of these inputs, respectively, only have one output. Okay, and I'm fine with that. The fact that all of these are the same output, I'm also fine with. This is a function. Bam, function. All right, let's look at B, letter B, number B. We'll call it, problem B. If the input is 8, I get a 0. Oh wait, sorry, no, I lied. If the input is 8, I get a 1. No, if the input's 8, I get a 2. Man, no, I get a 3. No, 4. Definitely a 4. I'm committed this time. Guys, here's a problem. This input, it is just giving me so many different outputs. This is so not a function. Not a function. All right. So I cannot have an input give me more than one output. That's a problem for functions. They don't like it. They just don't like it. Here we go. Problem C. If I input 1, everyone would agree. The output is 8. If I input 2, everyone would be, output is 9, Mr. Waddy. And I'd be like, you got it, friends. And then I'd be like, guys, I'm going to give you a 3. And you give me a, and then you're like, 11. Yeah. And then like the audience wouldn't know, right? When I say 3, you say, and then like you guys wouldn't know what to say because you're confused. It's giving me 2 different outputs. And then like the audience in this whole concert's going to fall apart. This is not a function. Not a function. Also notice we suddenly changed the way we represented this relationship. I had like this input-output table with little arrows going from each input to its respective output. So this is a different way that you can represent functions or relations, okay? In this case, if I got rid of one of these arrows, then it would have been a function, and it could have been either one of those. Here's a graph. Wow. Oh, you relations, you have so many ways of representing yourselves. I love it. So my inputs are down here. Input. Output is on the y-axis. All right, so you guys, oh, maybe it's been a while since you plotted points. We might get to do some of that today. But for instance, this over here, this point right here is the point, looks like over 3 up 2, so 3 comma 2. All right, so when I input 3, I output 2. Over here, when I input 1, the output was 6, if I want to write that as an ordered pair. This is a graphical representation, a scatter plot, if you will. I plotted the points on a coordinate plane, and this is a relationship. Inputs down here, outputs up here, so these points are like my battleship coordinates that I can figure out how to do this. Now, are any of the inputs giving me multiple outputs? Anyone notice? Yeah, it looks like 5 here. Uh-oh. And does anyone notice another issue? Let's see, it looks like 7 here also has multiple outputs for the same input. Okay. You guys spot that? How like if I input 5, I got both 4 and 5 back? And if I input 7, I got both 5 and 8 back? So this is not a function. No es. No es not a function. Here we go. Right. The whole graph was a relationship between these inputs and outputs. I don't know, these could have been ages and heights. Although a 0-year-old who is 8 whatever tall would not make sense. Interesting. I don't know. Very interesting. Yeah, but either way, whatever they were relating, it's not a function. Now, it's perfectly fine as a relation, okay? That those things do exist. We will deal with relations throughout your math career, but there's a value to kind of talking about the specific case of functions. All right, let's look at E. It says, let's see, here I've got a series of ordered pairs. I could graph these if I wanted, but let's just think about input and output. So here's my inputs. And do any of my inputs ever give me multiple outputs? So I've got -2 gives me 5, that's fine. -1 gives me 8, that's fine. 0 gives me 6. 1 gives me 6. Do I have a problem with these 6s repeating? No, because those are outputs. Outputs are okay to repeat. Notice even over here, I was actually okay with all 3 of those being the same height. I'm okay with those 2 being the same height. I'm okay with these 2 or these 2 being the same height. The outputs can repeat, but the inputs shouldn't so much, okay? Unless they were somehow just giving me the same point multiple times. And then let's see, when I input 2, I got 7. It looks like this one's a function. Function, all right? Because every input's giving me exactly 1 output. All right, does anyone notice a problem with F? Let's see, -2 gives me 0 every time. I'm okay with that. -1, uh-oh. Right here and here. Here, an input of -1 gave me 0. Here, an input of -1 gave me 1. It's unsure of itself. It's giving me 2 possible outputs. It's giving me 2 possible outputs. Not a function. So it fails for that point. The other points would have been fine. Let's see. Where do you see that? I'm sorry, I got lost. Okay. All right, good. Let's see. So 0 gave me 1, 1 gave me 2, 2 gave me 2. Those are all fine. I'm even fine with the fact that we got 2 multiple times. That's fine as outputs. I would have been fine getting 0 as multiple outputs. I would have been fine getting 1 as multiple outputs. But the problem is 1 input cannot give me 2 different outputs. So not a function. Not a function. I'm just thinking for some reason about the TV show Dinosaur Train right now, because my kids watch that, and they've got like this whole song about That's not a dinosaur. That's not a dinosaur. And like they sing about things that aren't dinosaurs. And that's what I feel like I'm doing right now. Like, that's not a function. That's not a function. And this is great. Like we're able to recognize right now what things are functions. Okay, here we go. Oh, this is weird. Guys, look at this one. So each radio frequency X in a listing area has exactly one radio station Y. Let's see. So the input of the frequency has one radio station, exactly one. That sounds like a function. Right? It would have been inconvenient if you tuned in to, I don't know, 100.7 or whatever, and there were two radio stations simultaneously broadcasting at that frequency. Like, that would not be helpful. No, thank you. All right? And notice it did say listening area. So yeah, theoretically, that same frequency could be used in a different part of the country. Let's see. The same television station X can be found on more than one channel Y. Not a function. I feel like this is a little bit of a weird situation. Like the fact that they chose television station to be the input, that's not really how it works, but it's rather contrived, but this would not have been a function because it would have had more than one output. Right, more than one Y. So not a function. Okay, here we go. Here's a new representation. X equals 2. My input always gives me the output of 2. I'm fine with that. That's a function. All right. Oh, wait. Oh, sorry. Oh, dear. I lied. Guys, I'm so wrong. Oh, dear. I'm bad. Check this out. Let's think about this as an input-output table. X is 2 all the time. X is 2 even when Y is 0, when Y is these things. It is not a function. My bad. Eventually we'll talk about the graph of this. That's a vertical line. So it would have failed graphically because it would have like had these sorts of situations occurring. It is not a function. My bad. Oh, my apologies, mis amigos. That's okay. We all make mistakes. I hope you guys learn from mine. Guys, you don't have to go out and live your life calling things functions that aren't. Learn from my mistakes. Come on, friends. All right, Y is equal to 2x plus 3. Is this ever going to give me, let's see, let's pick some values for X. I'll pick -1, I'll pick 0, I'll pick 1, I'll pick 2. -1 for X, 2 times -1 is -2, plus 3 is 1. 0 for X, 0 plus 3 is 3. 1 for X, 2 times 1 is 2, plus 3 is 5. And then this next one is 7. It looks like every input is only going to give me one output, so I believe that that's a function. All right, this is actually a linear equation. It's a line, and that's actually going to be a diagonal line, something like that. And for every input, there's exactly one output. Okay, so we just spent a lot of time going over a lot of examples, but this is good stuff. All right, it's good stuff. All right, I want you to be familiar with these different types of input and output, and we'll go through this next case faster. The more examples you see, the more your brain has the ability to kind of organize these thoughts. So let's go through this example fast. Ready? Rapido. -2 outputs 2. We're fine. -1 outputs 2. 0, 2. 1, 0, 2, 0. Function or not a function? I think it's fine. I think it's a function because every input has exactly one output. All right. B. Does anyone notice a problem with B? It's not a function. Where's my problem point?
4.
Yeah, 4 gives me 0 and 4 gives me 3. Not a function. Okay? All right, anyone notice a problem with this? C. Yeah, right here, 0 gives me 2 separate outputs. Not a function. All right, so we're getting used to this, like just seeing a lot of examples. Right, that's why I'm glad I printed this out for you today. Let's see, input. This input has one output. This input has one output. This input has one output. We're okay with that. We're okay if outputs repeat as long as there's not 2 arrows leaving the same input. So this is a function. Okay? All right, I know it's kind of like a weird idea, but hopefully you're getting this. All right, here, this is a nice test. I love this. This is a test you guys will like. It's not a test as in you have to tell me what you know yet. This is a test for you to determine functionness of things. This is called the vertical line test. That vert line. Here we go. It says this, a graph represents a function when no vertical line passes through more than one point on the graph. So check this out. Vertical line test, all of these points, a vertical line would only hit 1 point at a time. So this is a function. This is not a function, however. Here, Austin, if you don't mind. Notice over here, I draw a vertical line. It hits no points. That passes the vertical line test for that one line. If I draw this vertical line, there is a line that hits exactly 1 point. We're fine with that. It hits 1 point. But then the problem occurs like the one they drew here, or here, or here, or here, that it's hitting multiple points. That one input, remember the input is the x-axis, input is hitting multiple outputs. So it fails the vertical line test, because it hit multiple points at once. Okay? Notice up here as well, when we did this, that was actually what I was kind of thinking about right here. I was actually, in my head, thinking about this vertical line test, and I was like, those points fail the vertical line test. Okay? Makes sense, makes sense. Yeah. So let's do some quick examples of the vert line test. Get some vert. Vertical, by the way, is up and down. What's the word for side to side as a line? Anyone know? Horizontal. Horizontal. Horizontal like the horizon when you're looking at a sunset. Count it down, the sunset. Good times, good times. Let's see. Determine whether each graph represents a function. Explain. All right. Does this fail the vertical line test anywhere? Which points, if any? Well, this point? That's fine. Yeah, at 2, it fails the vertical line test. At 5, it fails the vertical line test. So it is not a function. It is a relation, but it's not a function because it has multiple outputs. 2 is giving me both 2 and 5. 5 is giving me both 1 and 5. Multiple outputs for one input. How do you guys feel about this? Yeah, I can't imagine a line that's going to hit, a vertical line anyway, that's going to hit more than 1 point. 1 point. 1 point. 1 point. So this is a function, right? Did I end up giving you guys more sketches with like the circles and the V's there? Yeah. I think I did. I'm gonna do those. I feel like this is like such a significant vocabulary piece. Let's see. That's good enough. I'd rather go through these examples so then your brain is able to like get this idea and sort through these super good. Let's see, I cropped off some numbers on the bottom. My bad, friends, my bad. All right, function, not a function. Let's see, number 5 here. Function, right? No vertical line would hit more than 1 point. Number 6, this is called a parabola, by the way. Later on in this class, we'll actually learn how to graph those. Function or not a function? Do you think there's a vertical line that ever hits more than 1 point? This is a function. And just in case you're wondering, this curve gets steeper and steeper, faster and faster over time, right? This one's like going up 1 over 1, up 3 over 1. It'll go up 5 over 1, up 7 over 1, up 9 over 1, but it's never going to become fully vertical. Okay, if you thought that was going to become vertical, or some people have asked, like, how do I know it doesn't like loop around and spiral? Then it would have failed the vertical line test. But just so you're aware, this type of curve will never become vertical. All right, how about question 7 here? No, does not. Circle is not a function. Fails the vertical line test there, It passes it over here. That's fine. Passes it right there. That would have been only 1 point. But it is not a function. Let's see this next one, like this V. That's actually an absolute value graph. We'll be graphing these at the end of chapter 3. Do you guys think this is a function? But look at this. Does it hit 2 points? Or am I tricking you right now? I'm tricking you right now. That's a horizontal line, Mr. Waddy. But as far as vertical lines, we're cool. Only 1 point, no matter where I draw the vertical line. Wow, man, that's such a catchy tune. I've got an uncle that's written jingles for commercials. He's retired now. With all that jingle money. Actually, he's got a recording studio, so that's probably where he made more of his money than the jingles, I'm guessing. Wow. Okay, here we go. Here's another way of thinking about functions. We call it input and output. And you guys got this little drawing. The idea of domain and range. All right, so here's a crazy machine. It's my 3 times machine. It takes what you put in it and it gives you 3 times as much when it gives it back. Oh, it's so great. I love this machine. 3 times. But here we're talking specifically about domain and range. Domain is the set of all possible input values. Okay, like what types of numbers can I throw in here? Could I throw a 0? Will a 0 break my machine? Can I throw a 4 in here? Yesterday, I put a bag of pellets into my pellet stove that had last year gotten a little bit wet, right? And it was fully dry now, but now my pellet stove's not working great. So I've got to like finish burning through all of that garbage bag so that way I can get back to good pellets, right? You only want to put things in the machine that are going to work. So we don't want to break the machine. So domain are the possible input values, and the range are the possible output values. What types of numbers can it give me back? Will it give me negatives? Will it give me 0? Will it give me positives, right? So that's what that's what we think about in terms of these words. Okay? So if I want to talk about domain and range, that's what I mean. So we know how to identify functions and relations, not functions. But here we go. If I want to talk about domain and range, we're going to talk about the possible inputs and the possible outputs. So for here, problem A, the domain, it looks like it inputs at -3. I'm gonna use this curly bracket notation here. -3. It looks like it inputs -1, right? It looks like an input is +1. And it looks like an input is +3. Those are the only input values I see for this function. If I told this function input 2, there is no output for 2, so that's not a possible input. Let's talk about the range. All right, so the domain, I was looking at these values. The range, I'm looking at these values, right? I'll actually even do it in a different color. Man, I've got to get better at. I'll have the most amazing. Man, that was so terrible. I will have amazing curly braces by the time this course is done. Just you wait, friends. I'm going to be amazing. You'll be so impressed with my curly brace bracket things. Okay, the outputs. Notice -2 is an output. 0 is an output. +2 is an output. And 4 is an output. Okay, so the range is talking about the possible outputs. The domain is talking about the possible inputs. Let's talk about this for domain. Okay, it looks like for domain, my x values exist from here to here continuously. So there's actually a couple ways I could describe this. I'd want to say everything between -3 and 3, right? Like those are my possible inputs. I'm going to use this set notation. The set of all x, this vertical line is like an absolute value bar. The set of all x, that means such that x is between -3 and 3. So I'll write this. -3 is less than or equal to x is less than or equal to 3. All right, that's a weird way to write domain. I also could have written domain this way. I could have said -3, comma, 3. And if I use square brackets, it means it includes the value. If this was an open circle, I would put a parenthesis here, and it would have suggested that it doesn't include 3, but everything up to it. So here's like 2 different ways of writing domain. I know this is weird. This is set notation. It says the set of all x such that x is between -3 and 3. Okay, let's talk about range over here. All right, so range. Could I get -2 out of this function? No. Could I get -3? No. The first value I could have gotten was at -1, and the biggest value I could get is at +2, and it looks like it gives me all values in between there. So I'm going to say the set of all y such that y is between -1 and 2. So -1 is less than or equal to y is less than or equal to 2. Is my, oh man, that was an ugly one. There we go. Or if I wanted to use the bracket notation, the bracket way of writing it is what I mean by notation. I could have said from -1 to 2. Okay, so the domain are the possible inputs. The range is the possible outputs. Oh my goodness. All right, we got to keep cranking here, friends. I think I've got one more example. I think. So we've talked about functions and relations. We've talked about domain and range. And some last terms we're going to talk about today are the variable, okay? The independent and the dependent variable. Here we go, here we go. It's going to be amazing. Don't you worry. Okay, so the input values, the variable that represents the input values is called the independent variable, okay? Because it can be any value in the domain. The variable that represents the output values of a function is called the dependent variable because it depends on the value of the independent variable. So like the output, the dependent variable will be determined by what I put into the machine. If I put bread in my toaster, the output is gonna be toast. If I put an egg in my toaster, the output is gonna be messy and burnt egg gunk, right? Like the dependent variable is determined by what I input, okay? So when an equation represents a function, the dependent variable is defined in terms of the independent variable. The statement y is a function of x means that y changes, y varies depending on what x is. So here's a function written as an equation where, remember, so far we've had equations where we've been like, all right, what numbers makes this equation true? And we've only had one variable showing up in most cases. We did do the solving of formulas and literal equations, but so if this was equal to 3, I would have asked, what number makes x true? Okay? But now I have 2 variables. And now what this equation represents is all possible combinations of x and y that make this equation true. There's going to be lots of them. I'll have lots of inputs with their corresponding outputs, and I'll be able to represent this equation as graphs, as a table, right, as an equation, all sorts of different ways. And that's what this is referring to. But the independent variable is the input, input, right? And the dependent variable is going to be the output. So let's do our last example, example 4. You guys already have this. It's gonna be great. Here we go. We're on the last example. Man, my songs are the best. Wow. Someday someone's gonna listen to these videos and be like, give that man an album. And it'll be great. And then I'll retire with my 48 cents from YouTube and my album money and my concerts. Oh boy, just you wait, friends. I'm gonna be famous. Let's see, example 4, identifying the independent and dependent variables. The function y equals -3x plus 12 represents the amount y in fluid ounces of juice remaining in a bottle after you take x gulps. Okay, I believe it, I believe it. Identify the independent and dependent variables. So let's see, independent. Which variable is independent? the x, the input, the number of gulps I take. And the dependent variable is going to be the number of fluid ounces left. Okay? So that changes depending on how many gulps I take. Makes sense. It says the domain is 0 gulps, 1, 2, 3, or 4 gulps. What is the range going to be? What is the range going to be? Now, we don't know how many... Oh, wait a minute. We do know. We do know. Guys, we can make an input-output table. Let's do it. Input, output. Actually, let's make a work column. Input, work, and output. I forgot. I almost was just gonna answer the question, then I forgot that they actually gave us an equation up here. Silly me. Salami, friends. Okay, so 0, 1, 2, 3, and 4. So if I plug in 0 for this, 0, negative 3 times 0 plus 12, negative 3 times 0 is 0, I would have an output of 12 ounces. Agreed? Yep. If I plug in 1, I'd have negative 3 times 1 plus 12, which is negative 3 plus 12, or 12 minus 3 is 9 ounces. All right, so I'm just doing my work over here to keep my scratch work all nice and organized. So I input 2. What's the output going to be? Any thoughts? Output when I input 2. 2 gulps will leave me with how many ounces of fluid? Let's see. Negative 3 times 2 is negative 6. 12 minus 6 will be 6. All right. So notice this negative 3 right here. This is like foreshadowing a lot for what the next 2 chapters is going to be. Notice that these are also reducing by 3. It's related to that up there. But I won't spoil the ending, don't you worry. Negative 3 times negative 3 plus 12. Sorry, positive 3, my bad. That's negative 9 plus 12. 12 minus 9 is 3. And 4 gulps, negative 3 times 4 plus 12. That's negative 12 plus 12, that's 0. So what do you guys think the range is here? Yeah, it could be 12, could be 9, could be 6, could be 3, could be 0. Oh. Now, if there's 12 ounces in the glass and if my gulps weren't consistent, then theoretically I could imagine it being anywhere between 12 and 0. Here they had very consistent 3-ounce gulps. Could I ever have a negative number come out of this function? What do you guys think? Could I ever have a negative number of ounces of juice remaining because I gulped too much? No. You can't have antimatter juice. They haven't discovered it yet. You can't have negative amount of juice. So this function, the range, only would have ever represented the most that could have fit in the glass, maybe 12 ounces here, maybe it fits 16, I don't know. And it could go down to 0. I could never get less than 0 ounces of fluid in a glass. No one is that pessimistic, right? There's, like the glass is half full, the glass is half empty. No one's like, no, my glass is like negative 6 ounces of fluid. Like, no, that doesn't exist, all right? There's no less than 0. All right, so we talked today about functions and relations, about domain and range, and independent and dependent variables. All right, a little bit of a long video. Always feel free to scrub through my videos, friends. Skip to the parts you need. Thanks for watching. Bye-bye.